Today, Chicago has experienced the lowest weather. It has reached -50. So, let us see what experiments we can do with this temperature. So, I have chosen three water bottles. One water bottle I'm going to place it in freezer, and two water bottles I'm going to place it outside to see which one gets ice faster and how the ice is being formed. So I picked the first water bottle and I'm placing it in freezer. Um, so I believe that the water bottle that is being placed outside will get frozen faster because the outside temperature is -50 Fahrenheit. It includes the wind chill. So with the wind chill, it should be -50 Fahrenheit. I'm placing two water bottles. So the one water bottle, the right hand side water bottle, I'm going to shake it periodically to see which one gets frozen fast. The other one I'm going to leave it as still, because normally when we see the lake water which is still, that gets frozen quick, and the stream or the river water gets frozen slow because there is a constant flow of water. So I'm going to try this with the water bottle. So the right hand side water bottle, I'm keep shaking it for every 10 to 15 minutes and placing it back outside. So let us see which one gets frozen faster. And I was checking the water bottle that was not disturbed, and still it's not been iced. Both the water bottles are still liquid, and the water bottle that is placed in freezer, that is also still in liquid state. So giving it some time, and it's almost an hour and a half. So now the water bottle which I was constantly shaking, it has frozen completely into solid, and the water bottle is very crystal clear. That is, the water after ice does not have any air molecules inside it, and it's very clear. So I'm checking the water bottle that is in the freezer. This is after 2.5 hours. Now the water bottle has been frozen an hour after the one that we have taken outside, and it has air molecules. This is the other water bottle which was undisturbed, and this is also frozen now, and this also is has a little bit of water, but it's frozen and it's much clearer than what it is in the freezer. But this also took almost 2.5 hours. So the water bottle which was shaken constantly, that was frozen quick, and the water bottle that was kept in the freezer and which was kept in the outside, both froze almost at the same time. But the only difference is the one that was kept outside and was frozen, that water bottle is much clear without the air molecules inside it. But the one I have placed inside the freezer, that had air molecules, impurities, and so it was not as clear as the one that have been placed outside. The temperature outside is -50 Fahrenheit. So I'm going to throw cold water into the air to see if it gets ice or if it falls as snow. But the cold water fell as a cold water itself. It might have got little bit more colder, but it's just water. So I'm going to boil the water. So I poured some water into a pan and I'm going to bring it to a boil state. After the water is boiled, we are going to throw it out in the snow to see what happens with this. I have seen in past some people have done some experiments that by throwing boiling water into the freezing cold temperature, the water falls back as snow. So right now the water starts getting to boil, and once this has been complete to the boiling state and we get more bubbles, we are going to take it out. Now the water is boiling and it has more bubbles. It has reached almost 100 degrees Celsius as it's reached the boiling temperature. Now let us take it outside to see what happens with this water. So I'm going to throw this water. See, you can see the stream coming out of the water. So I'm going to pour it in a container and throw it. Oh, yeah. Now it's falling down as snow, and as cloud forming. It's a beautiful spectacle. Yeah, this is what I have seen in the past, and I'm able to do it now because of the Chicago weather. I'm going to freeze this to show you how it's getting ice and snow.